Okay, let's get ready to welcome Yo Ameye. Yo is the general manager at Fluitec in Europe, and he's going to share with us his knowledge on managing hydraulic oil deposits by using novel solubility enhancing technology. Take it away, Yo.
Okay. Thank you, James. Um, just sharing my screen here. Good morning, afternoon. For me, it's just evening here in Europe. As James was saying, I've been with Fluitec for a little while. I first would like to thank my co-authors and Greg and colleagues, Christian Soto. And yes, today we'll talk about hydraulic oils. Though you know Fluitec is well known for everything and all the programs in turbine oils and compressor rotating equipment. I must admit that hydraulics has attracted a lot of our interest over the last 5 years. And yeah, just repeating hydraulics, it's one of the major characteristics of a lubricant, very often forgotten to under pressure, transmitting a power, like we can see on this robotics and surrounding us in major industries from mining, aerospace. But over the last, I would say, 5, 6 years, we've noticed some significant trends in hydraulics industry. And knowing that equipment have to deliver higher pressure, higher output, working also at higher temperatures due to smaller oil systems, higher circulating rates, which means there's more contact with air. And last but not least, think about everything around us on sustainability, lower leakages rates. And this has led to the fact that for hydraulics, the number one failure mode is coming up as being oxidation. And oxidation, for those who are not aware, it's the reaction of oxygen with mineral or synthetic lubricants. And over the years, where it was known as a famous issue in turbine systems, we saw more and more deposits on hydraulic components like this servo valve. We recognize this typical orange color on pump seals. Just see how this seal has been totally corroded by deposits and very often neglected as a main root cause, or filters which suddenly are having short lifetime, and very often people or operators, when they take out a filter, they can, like you see on this small hydraulic filter, see how you can take a gel off of the outer layer. It's a soft contaminant, or a deposit in hydraulic system tanks, reservoirs. You recognize also this typical brown orange deposits color. And so this contamination being unknown for years, suddenly, or not suddenly, but operators were realizing it had an impact on the performances. Think about the speed and cycling time, because we know varnish is creating more friction. It also causes repeatability issues because of pressure changes. Accuracy, if you walk through a plant, you can see when the scrap is next to the injection molding machine due to erratic cycle times from, for example, the molding machine, when varnishes occur, valves resulting in slow startups. And then if you go and talk to a hydraulic plant, they will exchange you information by saying they have more problems with the heat exchanges, not being able to decrease the oil temperature in the coolers, even leakages on pumps, resulting to pump repair costs, as you can see on these pictures. Filter lifetime, typical problem because of deposits and contamination, these soft contaminants known as varnish. And yeah, of course, then often resulting in higher cost of maintenance. And if we then look at, we take a helicopter view, we try to understand where is now all these deposits or this hydraulic contamination causing, where is it coming from? We can make distinction between four major categories. The last one I will certainly take as one of the case studies I will present. Think about incompatibility between zinc containing and ashless hydraulic oils. Water, of course, also contamination, specifically solid particles. Think about mining environments, cement factories. Thermal degradation, yes, indeed, lubricants are highly refined. They have a higher, I would say, a much lower conductivity. So when you are filtering too fine, you're creating spark discharge, micro dieseling because of, like I told you, this sensitivity for air release, separation or air separation. And of course, oxidation, accelerated with the presence of oxygen, contamination, but mostly these higher pressures created in hydraulic systems, and the pressure drops you're creating and issues of oxidation. And as you know, Fluitec, we have years of experience in oxidation and understanding oxidation reactions. Just think about the ruler technology that we have developed. I like this one-liner receiving from my friend Greg, which I really like. What you don't measure, basically you can't manage. I heard a session today about the managing your boss. Well, I think maybe this will also apply by the keynote speaker. But yes, what can you find behind this one-liner? Let's look a bit on hydraulic oils. What do you really need to measure on hydraulic oils today? What you find today in an analysis program, absolutely viscosity. Yeah, we know it's still a major parameter. Contamination, hard contamination, mostly today. Then interaction with contamination, the wire problems who can occur, or with water, hydrolysis, oxidation. We talk about chemical changes and oil degradation. Are all of these parameters today addressed correctly? I would say no, not entirely. There's today, specifically with the change in operating conditions and the higher load factors of equipment, hydraulic oils need special care and follow-up. And it's been changing. And so let's address these changes which are necessary. So contamination, I believe people are in front of the screen here in our hydraulic oils specialist. I think there's enough specifications today talking about wear metal, contamination, water, ISO particle counting classes. We all know, especially for hydraulic systems, how important it is. Then we think about oil degradation. Yes, that is changing a lot. If I tell you that oil systems are getting smaller, the acceleration of degradation can be more significant. And today, this degradation is measured by parameters like viscosity increase, acid number. And yes and no, will it address some of the contamination that you saw on the picture, these brown, varnished, soft contaminants? Well, no, it will not measure it. And that is often a shock for a hydraulic user, because they don't have that information in hand and still see all the problems. So a technology that has been growing in importance over the years, and today for hydraulics, we can only share our strong recommendations as a high added value test. It's the membrane patch colorimetry, better known as MPC. The MPC is a method has proven value into rotating equipment, turbine oils, but yes, also for hydraulic oils and even for phosphodesters oils. Lately, we adapted the ASTM 7843 for phosphodester oils. And by looking at the hue and the color of the patch, we are able to identify the high amount of soluble contaminants, as you can see on these patches. So an MPC test today cannot be, I would say, it can be of extreme high value for understanding how an oil is degrading, hydraulic oil. Once you understand that there might be an accelerated degradation, you might have an idea of understanding this by looking closer at how additives like antiwear or antioxidants are depleting. Methodologies for detecting like that are technologies like it's a linear steep voltammetry or infrared. And understanding the trend of antioxidants helps you to understand also how quickly your lubricants are degrading. Proven technology into turbine markets, but also now appearing of high importance into hydraulics, because we see a change over the years from group 1 to group 2 base oils for hydraulics, which are additivated with specific packages of as ashless antioxidants such as amines and phenols, which are giving the oil additional life and protect the oil against these higher operating temperatures. So understanding the degradation and also the antioxidants will give you will be of significant value. Just as we see here, this is an infrared graph for zinc-containing oil as an anti-wear additive, multifunctional anti-wear additive if you want. And asset number, I receive very often the reply, yeah, we look at our asset number to monitor depletion of our zinc. Dithiophosphate, that will not help you. There might be some indication, but it's much more accurate to follow up like technology like infrared, where you look here on the band of the spectrum of the POC. The POC is the group of the active group of your zinc dithiophosphate in this case, and showing you how it is depleting and showing you, giving a good idea of fluids mode of degradation. So you have established a good oil analysis program. You identify the higher presence of soft contaminants, deposits. You know that there must be premature degradation, either by oxidation, either by thermal degradation. I still think that ESD, electrostatic discharge, and cavitation or the microdieseling can be of high importance of fluid failure, of fluid degradation and leading to fluid failure. So, but then you identified the contamination. Is there anything you can do other than just change the oil and try to avoid the problem in the future? It will not go away. So over the years, Fluitec, we have been looking at one of the options that we can do is looking at fluid enhancements. And the fluid enhancement is increasing the solubility. Solubility, as we all know, is a major chemical characteristic, physical chemical characteristic of any fluid. In this case, we talk about mineral hydraulic oils. Solubility for, like you understand, degraded antioxidants, degraded base oil, even I would say degraded anti-wear additives. And to eliminate those deposits, we have looked at increasing solubility enhancement, either with two functions. It's looking at optimizing the decontamination, optimizing and achieving optimum cleanliness, and also avoiding deposits. So controlling the deposits so that you can go for long-term operating systems free of deposit sludge and varnish. And so the solubility enhancer is like a technology which is making deposits reverse, so you can reverse, bring them back in solution um, layer by layer. So it's not like a sudden dump of all the contaminants. Layer by layer, you're gonna dissolve your deposits and think about your cooler, think about valves, servo valves, proportional valves, gears, and though the solubility enhancement is shown to be a very efficient technology. For chemists under you, it is group 5, let's say it's technology based on group 5 chemistry. 100% group 5 chemistry. We do not use any additives or detergents. Let's be clear on that, because that's often the question that we see. Are these additives? So yeah, we don't want detergents. Absolutely don't use detergents. Let's be clear on that. But the base oil here has a superior seal compatibility, proven to give excellent oxidation stability. In combination with deposit control, you avoid all these free radicals to react. And absolutely, like I told you, it will not affect any of the major characteristics of the oil, like air release, foam, or the emulsibility, as you know, are critical parameters for hydraulic oils. And here we see then such a fluid where you can see this is a hydraulic zinc containing hydraulic oil, and lower we can see the lower patches. The 3 patches is patch after 1, 3, and 6 weeks of oxidation test. And by this oxidation test, we can gradually see the build-up of the deposits. When we take that same oil and we treat it with the 5%, that is usually the average concentration of treatment that we use for treating these hydraulic oils, we can see that absolutely the patch values at MPC are remaining below 10, so single digits, 5, 4, and 8. Keeping all these soft contaminants nicely in solution, avoiding that they're gonna form deposits and keep your system full. I hear questions probably in the audience. What do you do with all these inorganic hard contaminants which are often glued into the varnish? Yes, they do. Think about Dr. Sasaki's sandpaper pictures in the 1890s. Well, here we have seen how we slowly release layer by layer the varnish, and it can be that these small contaminants, hard contaminants, can then move to your fine filters, where we often advise to use that media in combination with soluble contaminants. Good. I have a few case studies here. I see 15 minutes, so I have a good 10 minutes left, if I'm correct. So I'll be fine in timing, James. We have 3 cases, 4 cases. Injection molding company, a company who came to us and basically telling us that they were having between 150 and 200K per year on maintenance budget, abnormal maintenance budget. I just heard the speaker before me about maintenance departments cutting costs. Well, I think if a plant is able to look in depth on the actual maintenance cost, they will be surprised how they could cut cost on that aspect, and not just by cutting in the department itself. But and anyway, in this case, what we noticed also immediately, we instructed the plant to do an in-depth oil analysis program, and we noticed high NPC values, averaging 35, high acid numbers, and even we noticed zinc phosphate in ashless hydraulic oils. How could that have happened? Well, yeah, how it happened, we don't know, but these are the consequences of it. These are actual pictures, realistic pictures from some components of net-style injection molding machines. You recognize again the nice typical orange color on these components from a pump. You also see the really the black brown deposits here on all the metal components, even creating here wear, as you can see, and then leading to failing pumps. MPC analysis also, as you can see, too high, an increasing trend with zinc, as you can see, just too high for an ashless oil, which after the end we found out that together with acid number, that on a few machines, zinc containing oil was mixed in this ashless oils. But case study, we added 3 to 5% to the 25 most critical machines, followed with a detailed oil analysis program, monitoring closely filter life and valve performances. And this plant is now 2.5 years, was our first case study in Belgium. And we could notice how when you see the blue lines is the MPC values fluctuating before treatment. And you can see after treatment in a very short period how MPC values all went in the normal value of less than 20, resulting in averaging 12 DE for those 25 machines, improved cleanliness codes, stable filter life. So the problems was solved, and now the customer also moved to a high performance, high toast to hydraulic oil. Another case study we have from in the US, one of my US colleagues, also injection molding. Typical problem is these clamp speeds reduction leading to lower productivity. The solution was the solubility enhancer, which was used, and as we can see again, this nice and typical drop of MPC. What does not mean your varnish is disappearing, ladies and gentlemen. That means that your capacity of keeping the varnish in solution is increased. That's a big difference. Even thin film deposits proves that the deposit was mostly much better under control. And with the mold change, the downtime reduction of over 66%. In today's economy, this is of incredibly high value, where economics and energy costs are very actual. Last case study is a case we had from automotive industry. That is a large press. Here we see a component of this steel plate press, 1800 ton. And we can see again here the typical color of orange on the servo valve, which is was creating say maintenance issues, shutdowns, and for steel plate press, where in automotive industry there's a continuous process, this can be of very high cost. So also here immediately we started treating with solvency enhancer, so the solubility increases. And we can see how then particle counting is, except for those two outliers here, is getting under control. But MPC, as you can see, is getting really under control. The fluctuations we see is also because what we do, we combine it often with the depth media filter. For once you release some of the deposits, that you can remove them and avoid that they start to build up again. Some deposits, because also solubility has a limit. You can see that the trend, this plant also is working problemless since then, and for them it was an enormous cost saving. In addition to that, with solubility enhancement, you also offer the possibility, once you clean up the oil, you can also extend the lifetime of the oil. And for hydraulics, talking about systems like 20, 30, 40,000 liter oil, adding what is being consumed, meaning antioxidants in combination with antiwear, is a solution that is very effective, is 100% related to sustainability, which at Fluitec is part of our core mission. So this product is used in this same plant, not the same press, but in Czech Republic. And what we can see is that with gravimetric as well MPC during construction, how suddenly they are increasing and creating valve failures. After treating this with the solubility enhancer and the additive package, we can see how very quickly, look at the dates here, we're talking about 3-4 months, how you're getting a quick drop of MPC and also gravimetric and stain, and that is quite important, stable. A slight increase here is normal because you're cleaning up the system and missing deposits. And most important, no valve problems anymore. Bringing me to my conclusions, as you understand, technology today changing a lot in hydraulics, more stress, more oxidative conditions, new formulation changes, needs different condition monitoring strategies. Absolutely no doubt about that. MPC is one of the good technologies for that. If you are able to define the root cause and understand the contamination issues and wanting to stop the further degradation, then increasing solubility or solubility enhancement is a very effective and efficient tool, and in order to remove the contamination on hydraulic systems for a wide range of fluids. So that's what I wanted to tell you. I would like to thank you for your time. I see there's a few questions, so I will now just listen to James, what he has to tell me. Thank you very much for your attention.
Are you going through the chat box? Yeah, there's a couple on here. I had one. Combined with decon, do you have a preference when you do have the ZDDP fallout in these ashless formulations? Do you have a preference on filtration method, like depth media versus electrostatic? Is there something you feel works best?
Well, that's a very good question. And you know, one of the things I learned in hydraulic industry is that they're very cost aware. So, well, you're not going to come up with any, I would say, additional costs. So, if not necessary. Now, solvency enhancement is a slight cost. It improves also the quality of the oil, no doubt about that. So, with filtration, we rather go for efficient depth media. Because you make agglomeration of some of these deposits, especially if they're zinc-based. And I must say, we have the best results with depth media, which are today, I must say, belong to the state-of-the-art technologies.
Thank you.
The only thing you need to do with these technologies is that you need to look at your oil analysis, clearly watch the MPC and particle counting, and it will help you then also, I would say, understanding when you have to take action. I don't think you need to use constantly the depth media filters. What we have noticed, once the system is clean and you can keep it with good solubility enhancement, there's no further needs to absolutely use depth media. So it's more in the early stages where you have a high amount of deposits formed and released. So I see that Wanda had also, yeah, okay, I agree with her. She already answered the question. It's easy when people make a chat and ask the question and answer the question. So that's looking pretty interesting. Oh, okay, then I think we're ready. We're in time here, James. Can we? I think we can stop the presentation.
Yes, I think we're
I
good.
wish.
Yeah, I think that's all the questions.
Yeah, I wish to thank you, James, for helping me and being my moderator. And once again, I would like to thank my colleagues, you know, Greg and Christian, which I must be around there somewhere with you there. So you can say hi to them, thank them, and I wish everybody a good LRVS. We have another LRVS in 1 month time, exactly the 19th of October in Europe. We have also some very good speakers there from international companies like Siemens Energy, BASF, Solar, Aramco. So really a very interesting agenda. note that 19th of October, I'm sure our marketing department, including Sanya and Josh, will send all the data out. But I will be welcome to hear and see your participation. But now enjoy this LRVS Americas, and I'll take care, all of you. Thank you very much.
Thank you, Yo. Nice job.
It's the 18th of October. I miss myself, LRVS. Thanks, Randa.